So hello, everyone. I represent Thorlabs, a photonics manufacturer, and we manufacture and develop all the items that you see here. So we have mechanics, optics, light sources, light detection and analysis, motion control. I could go on all the way up to complex systems such as microscopes. We're headquartered in New Jersey, and the team that developed the item that I'm going to show you today is located in our Munich facility. So today's topic is quantum test and measurement, right? And things tend to get ugly pretty soon, as you see here on the table. So we manufacture all of this, but when we talk about quantum test and measurement, the expectations get higher. So for example, you might need a very low noise laser source. You might need optics that are more stable with regards to thermal drift. And for example, you might need a special detector. And that's what I'm going to talk to you today about. It's our new single photon detector, SPD-MA. It is a Geiger-mode avalanche photodiode, which means that even a single photon already gives you an output pulse. It has a really small footprint. So to the best of my knowledge, it's the smallest that you can buy out there. And we achieve that by two things. First of all, a highly efficient tech driver. We're strongly vertically integrated at Thorlabs. So we actually do these ourselves. This comes in a small SMT package. You can purchase these in high volumes. And these are highly efficient, meaning very low heat dissipation. And secondly, the entire thermal design of the detector is really well done, so we don't even need cooling fins. One nice aspect of it is that you can change the overvoltage, meaning you can tailor it to your experiment, either minimize dark count rate or maximize the photon detection efficiency. And lastly, it has a very large active area of 500 microns, which is especially suited for free space applications, but you can easily fiber couple it through those mechanical ports here. So the takeaway being, it's a great detector in a really small package. Now we tested this detector in real life situations, so we were sure that it's up to par. And one of the beta testers was the University of Hanover, where they did a single photon interferometry experiment, and I'm going to walk you through it. So at the bottom here, there's a blue laser that goes all the way up to a non-linear BBO crystal where a pair of photons is generated. They travel to the detectors up here. A beam splitter guides parts of the light down towards a Michelson interferometer, at the output of which there's the third detector. Now, as you probably know, in a classical interferometer, when you change the length of one arm, the output pattern will be an oscillatory behavior. And the same is actually true for single photons. So even single photons show interference. This is what they demonstrated here. And again, let me point out the small footprint. So when space is at a premium, this is a really great detector. So the takeaway being here, it's a field-proven detector, plug and play. You can just put it in your experiment, hook it up to your electronics, and you will see the output pulses. Finally, a little output. So there's more of these detectors to come. The group that develops these is in the second floor of our new Munich facility here. They're developing more of these. And it's probably interesting for you to know that we actually ship these same day. So both from our facility in Munich as well as our headquarters in New Jersey, they ship the same day. We keep these detectors and everything else that we have on stock at all time. Finally, let us know if you have any feedback, product ideas. We're really all ears. If you're looking to implement a specific application, or if you're looking at an OEM project, we're really here to help. Just get in touch and drop us an email at europe@thorlabs.com. Thank you very much.
So it's great to see Thorlabs has an off-the-shelf single photon detector that ships the same day. How about the rest of this setup? Can someone just buy this whole setup and build their metrology in lab without having to go to multiple vendors?
It's funny that you should ask this, because we do have a line of educational kits. For example, an atomic force microscope, very cheap and versatile, a quantum cryptography setup, for example. So if you want to look at an actual protocol for quantum cryptography, you can buy this. And we're currently thinking about adding this one here as well. So you could really buy this as a one kit option with a proper manual how to set it up. So this is something that we're thinking about. If anyone's interested, again, please drop me an email.
Great. Thank you, Jens.